we're moving on to the natural base e. E stands for 2.718. It's kind of like the number pi, it just keeps going on forever. But it... Is E the golden ratio? I should have looked this up before teaching. I think it's the golden ratio where, like when pictures and stuff have it, it's like mathematically pleasing to look at. Yeah. So, for now, yeah, second one. We treat the E like a variable. Remember when I taught you exponent properties, all I had to do was add. So on number 1, to simplify this one, I just add the 2 exponents, and it simplifies to e to the 9th power. Even though e stands for something, I don't have to actually solve it all the way out. Okay, so on number 2, I want to start by dividing the 16 by 4. 16 divided by 4 is 4. And then I subtract my exponents because it's division. 5 minus 4 is 1, so I don't have to write it. Questions on 2? On number 3, I want to distribute my exponent in. The 3 has a secret exponent of 1. So then it becomes 3e squared. Wait. What am I doing?
3 squared.
3 squared, and then e to the negative 8. No. What's 3 squared?
6.
Try again. 9. And then e to the negative 8, because it has a negative exponent, it turns into a fraction and it moves to the bottom. It has a secret exponent of 1. And then I multiply the 1 by 2. The exponent stands for how many 3's I have. I have 1 3.
Negative, you make it a fraction. The whole equation.
There's always secret exponents of 1 if it's not written. Yeah. 2 times negative 4. So like, right here, this has a secret. No, there's no squares. It's a secret 1. Yeah, if it doesn't have an exponent, it has a 1. So right now this... No, in general. Yeah, the exponent represents how many of each number I have. So, it's not only 3. I'm trying to tell you right now, if this 4 has a 1 and this e has a 1, but I don't have to write it. From yesterday? In the back of the Monday folder. What? No, it's not because it has an e, it's just because there's 1 4. They all have secret exponents of 1. Always. It's because it appears that it has an exponent. So if we have e, the way we tell if it's exponential growth or decay is if we look at our exponent. If it has a positive exponent, then it's growth. If it has a negative exponent, oh, no one still needed 1 through 3, right? Okay. If it has a negative exponent, then it's decay. So if I take a look, is number 4 going to be growth or decay? And why? Why? Okay, so the exponent is not negative, it's positive. So then what do I want to do here? Figure out what the graph is. What? That's not what I was asking, Jerry. Yeah, it's because... Yeah. When the base is e, we look at the exponent. So then what I want to do here is I want to go and graph this. Where is e on the calculator? So I type 3, and then e is, you see this button that says ln? Right above it in blue is e, so I'm going to go second ln. And then I type x.
Oh, so e is that number?
Yes. What? Yeah. On Desmos, you just type the letter E. Okay. Then I go to graph. And it looks like this. That's a very ugly arrow. Questions on 4? so then on number 5, it's going to be decay because my exponent is negative. Okay, so then I go and type this one in. And then I go and graph it. No, you don't have to put zeros before decimals. Okay, so questions on these two. Growth and decay. Then on number 6, it wants me to graph it and then say my domain and range. You guys still need 3 or 4 or 5? So on number 6, I'm gonna go graph this. What? Oh, okay. Dang it. Oh, no, that's fine. Okay, so what is my domain on this graph? All real numbers. I can plug whatever I want in for x. Yep. My range? Where does it kind of flatten out at? 0. So it's going to be y is greater than 0. Because it keeps going up, but it can't go below the 0. It never actually touches 0.
Because range is the output, right?
Range is, yeah, up and down, and domain is left and right. What? On range?
Yeah.
It's just greater than because it's not equal to, because it gets very close to the 0, but it doesn't touch it. Domain is left and right. It keeps going left and right. Like, I can plug in 1,000,000 for x, right? The number 1,000,000. I can plug it in, so that's why it's all real numbers, because I can plug in any number I want for x, but when I graph it, I don't get anything below 0, so that's why my range is restricted. Just greater than, not equal to, because it doesn't actually touch that. So then, I want to graph number 7. Okay, so this is what I'm typing in. Then I go to graph it, and it looks like... Dang. Okay, so what is my domain and range on 7? Domain is still all real numbers. The only times it's not is when we work with those radicals. So like last chapter. Remember with like the square roots and stuff?
So this chapter is always
No. When we have exponents of x, yes. But the second half of this chapter, no. Okay. My range here. -1. But just greater than, not equal to. Because it's shifted down 1. Because if I actually look at this calculator, Jerry, it flattens out at -1.
Oh, so you're looking at it from up to the left, or you're looking from left to right?
I'm looking up and down for range. And my lowest point is -1. From there, it keeps going upward.
Oh,
Yeah. Also, if I look at my equation, it's got -1 at the end, and that's where this -1 is coming from.
okay, yeah.
when you have exponents of x, it's never equal to. Any other questions here? I think there might be in the second half. But as long as we're dealing with exponentials, it works without. Is there more examples on the back? Okay. Oh, okay. Another one. So, another way to define compound interest is this formula, A equals P E to the RT. Very similar to yesterday's. P is the principal, R is the interest rate, and T is the time in years. E is obviously the number 2.71. So, number 8 tells me my friend has a bank account. No, is this me? The first bank account is me, and the second bank account is my friend. I want to see who has more money at the end of 3 years. So, what I'm going to do is, the first thing I'm going to do is I'm going to plug in 3 into this equation. How much money does my friend have? No, that's me. How much money do I have at the end of 3 years? Okay. Then to figure out my friend's money, this is going to be the formula we learned yesterday for compounding. So my friend has the $4,500 as her initial balance. Yes, that's, yeah. Okay, her interest rate is 0.04 and it's compounded monthly. So that's my N, and then T is 3. So 1 plus 0.04, 12 times 12 to the 3. She has more money than me? Wait. Yeah. Yeah. No. I think you took the number wrong. Oh, okay. So, who has more money at the end of 3 years? Me. So, account A. Could only have like $1 more. So, in general, if they're exactly the same percentages and times, as well as initial amount of money, the E accounts, the accounts that are compounded continuously, always make more money. Because it's happening on a more frequent basis. Questions on this example? Okay, then take a few minutes to work on the 8 below.